All right, so here we have a table that says the probabilities of the makeup of a class, okay? In this one particular class, we have 4,900 males. 4,900, okay? Blake, are you with me? Well. We have 7,500 is the probability that someone is white in the classroom. And 1,300 is the probability that someone is left-handed. Okay? So those are all probabilities. Use the table to answer the following questions. Does the fact if someone's a male determine whether or not they are white? No. Does the fact that someone is left-handed, does that help determine that somebody is male? No. So these, again, are all independent events. Okay? They are independent. And if something is independent, you just multiply. Okay? Bruno, did you hear that? If they're independent, then you just multiply. So, what is the probability that a person is male and left-handed? Well, male is 0.49. Left-handed is 0.13. I need to multiply those two together. Amani. Come on. Let's keep our heads up. All right? You need to write this down in here. Let's go. Independent events. Can you multiply those together and tell me what we get, Kimberly? Please. Six, eight, seven? 37. All right, so the probability that we get a male that is left-handed is going to be 0.0637. Again, when you have independent events, you just multiply them together. One does not affect the other. Letter B, what's the probability that a person is male? Well, it's still 0.49. That they are left-handed, 0.13, and white. And that is 0.75. We multiply these all together, and if my answer before was 0.0637, the only thing I changed here was I multiplied by 0.75. 0.75 is less than 1. So does that mean my answer is going to be smaller than the answer above, equal to the answer above, or larger? Should be smaller, yeah. If this was 1, it would be the same. If it was a higher number than 1, it would be bigger. But this is smaller, so my answer should be smaller. Who can multiply those all together for me? Give me an answer. Alexis, you with me? Okay. 0.0477, and that definitely is smaller. Good. Any questions about those two? Letter C, what is the probability that a person is female? Female, we don't even have female up there. And left-handed. Okay, I know what the left-handed is. That's 0.13. How could I find the probability that someone is female? They don't even give it to us, Miss Thede. Come on. So the probability that a class that you've got a male is 0.49. What's the whole probability? Not necessarily 100. You're close. You're thinking correctly, but it is. So, yes, you take one whole to find the probability that female. You take one whole minus the probability of male, because if you believe in two genders, most people do, you're either female or male, right? So 1 minus 0.49 is going to be 0.51. So the probability that someone is female is 0.51 times 0.13. That should be a little bit larger than the first one, which is 0.0. Who is that? Yes, are you trying to be funny?
It's not me. It's not. It's literally one. It's not me.
I think it's Blake. That table is really shaky, but I don't think you're shaking. I don't know. Who's got the answer? 0.51 times 0.13? Guys, you have the calculators. 663. Thank you. Jonathan, put the phone away. Keep the phone away. Not just put it away, keep it away. Any questions on how to find, if we give male, how you can find female? All right, turn the page. Conditional probability. Conditional probability is when a probability is dependent. When probability is dependent on another event. It's kind of like a dependent event, only we are talking about probability. So if it's probability, you have to have a numerator and a denominator. Okay? Now, up until now, we have always been talking about the denominator should be our total number in the corner, right? Total number in the corner. Now we have this vertical line. If you look for number 2, there is a straight vertical line here. That line means given that. Okay? Given that. Yes, you should write that in. Don't eat that now. Don't eat that now. Okay. What does that say? Okay. Given that. And what follows that vertical statement is going to become your new denominator. So that's why denominator. That's why this is conditional, because it is no longer over the whole thing. It is now over this new denominator. So you were right. I'm sorry. Thank you. All right, here we go. So it says translate the statement. The statement is, what is the probability? What is the probability of a person being over 6 feet tall, given that, and you literally do say given that when you see that vertical line, they are on the basketball team. This is conditional because there's a condition. They have to be on the basketball team before I talk about their probability. Okay? It's not everybody in our class. They have to be on the basketball team. Okay? Oh, here we go again. All right, all right. Number 3. What is the difference between these two statements? What is the probability of selecting a red car given that, this is given that, you look at all two-door cars? So you are looking at, okay, you are looking at all two-door cars. You're looking at a Porsche. You're looking at a Ferrari, a Lamborghini. You're looking at a Pinto. You're looking at one of those little mini cars. I don't know what they call it, a smart car or something. I don't know what they call those. You're looking at all of those two-door cars, and out of those two-door cars, we want the probability of getting a red car. And it has to be a two-door car, since you're looking at two-door cars, right? That's what this one means. This one means we are looking at all red cars. Hi.
Hey, how's it going?
Good.
If I steal Alexis?
Sure.
If you need
I
her,
think
stay.
she was just gone.
Okay, if you need her to stay, that's fine.
Like she just came back from there?
Yep. If you want her to stay, that's fine.
Does she need to go? She should, maybe.
I'm flexible.
Should we ask her?
If you would like.
Would you like to go? Ooh. Huh? Can you get that later? Is that what you're saying? Yeah. Okay. So here we are looking at all red cars. So we have red trucks, we have red vans, we have red 2-doors, 4-doors, we have Lamborghinis, all those kind of red cars. And out of all that sea of red cars, we want the probability of getting a 2-door car that is also red. Okay? The probability of a 2-door car that is also red. All right? Any questions about that? I'm sorry? When did this turn into English class? Right now. I know, this is a lot of writing, right? It is a lot of writing. But do you understand the difference? You have a sea of red cars, and we're looking for a 2-door that's a red car. Thank you. And the other one, we're looking at 2-door cars. This is the given that statement. This is the condition. They have to be a 2-door car. And then we want red cars that are 2-door cars. All right? Okay. Conditional probability. This is how you find conditional probability. The probability of A given that B, and this is what, oh my gosh, I just forgot his name. The basketball star at the very beginning, the probability commercial, LeBron. This is what he was talking about. Conditional probability is equal to the probability of A and B given B. So this B down here is your new denominator. denominator. Okay? The probability of A given that B means B is going to be in the denominator, and then we need A and B on top. All right. I'm sorry? Still like 2 weeks. You have a skills check on Friday. I'm going to do fantastic on it. I think it's 15. That's not that much. All right, here we go, guys. So we have a table. This is a two-way table. We have gender on the left, preferred programs on the top. So the first one, this is conditional. The probability of selecting a woman given that she prefers to dance. Okay? Given that makes it conditional. She has to like dancing. Well, how many total people like dancing? 18. So this becomes your new denominator. It is no longer the total in the corner because it follows this conditional statement. Now, of those 18 dancers, how many are women? And of 18, if you only have 18, 16 are dancers. And let me preface this by saying we are not reducing. We're not going to reduce, okay? We're just going to leave it with the numbers we have. All right. Any questions on that one? So you are coming up with a new denominator here. All right. What's the probability that someone likes movies given that they are a man? Well, I need to put men down here at the bottom. How many men do I have total? 20. And of those 20 men, how many enjoy or prefer movies? 8. Right here. 8 out of the 20 prefer movies. But again, this is conditional. Blake, you want to be cleaning my tables? Come on. 8 out of 20. The next one, the probability of choosing a dancer given that, there's that given that, they are a woman. There's a condition. You have to be a woman. Well, how many women do we have total? We got to look at total. And then of those that dance, that is the 16. Yes. There you go. You were just ahead of your time, Atu. Yeah. Does everybody see how I'm doing this? We've got a new denominator. And the last one right here, the probability of selecting a man given that the person is and likes sports. So what's that new denominator? What's my new denominator here? 16. Think of this vertical line as your vertical line that falls to be horizontal. And then 16 is your new bottom. Of all sports fans, how many of them are men? 10. So that is 10 out of 16. Okay. Let's keep that tablet put away. Keep the tablet put away, please. All right. Now, take a look at this one. Is there a conditional vertical line here for the probability of not liking to dance? Is there a vertical line there? There is no vertical line. So what should I go back to being my bottom denominator here? 50. Yes, because there is not a condition. Now it goes back to the total. So this is regular old probability. The probability that someone doesn't like to dance is all of them, which is 1 minus the probability that someone does like to dance. So all of them would be 50 over 50, that's everybody, minus the probability that someone likes to dance, 18, I'm trying to show both, out of 50 means it is 32 out of 50. Because you either like to dance or you don't like to dance, right? Do we need some help with the knot? Is not difficult for you to understand? It is. It's a little confusing. I'm going to do an extra thing with that tomorrow. Not. All right, and the last one. Is this a conditional? Do I have a given that on that? No. So what's my denominator going to be here? 50. That is your total for the whole thing. And I need dancers and men at the same time. So find your dancers, find your men at the same time. It is 2. 2 out of 50. Questions on that? Okay. I think I'm going to stop there because tomorrow we're talking about the Titanic, and that's pretty big. The Titanic. Yeah, we're talking about those that got in the lifeboat, those that didn't, first class, second class, third class. Just a reminder. Just a reminder. Bless you. Just a reminder, the third homework is due Friday. Skills check, Friday. And Canvas activity due on Friday.